So in section 3.4, we're looking at the zeros of a polynomial function. And zeros are always the values of x that make the function equal to 0. So there's a rational zero test that basically says that there's some sort of relationship between the leading coefficient and the constant term, and that's what creates a list of possible zeros. So all of our possible rational zeros are always found by taking p and dividing by q, where p is a factor of the constant term and q is a factor of the leading coefficient. And of course, p and q have nothing in common other than the number 1. And so, for example, if we're looking for the possible rational zeros of these functions down here, when we take p, which is the 8, and we find factors of 8, things that divide evenly into 8, we get positive and negative 1, positive and negative 2, positive and negative 4, positive and negative 8. When we take q, which is the leading coefficient, and we find things that divide evenly into q is 1, we get positive and negative 1. My possible zeros are going to be p divided by q, so it's positive and negative 1, positive and negative 2, 4, and 8, okay? If we're looking at b, my possible zeros are going to be p, which is positive and negative 1, positive and negative 2, positive and negative 4, over q, which is positive or negative 1. So the possible zeros are just 1, 2, and 4. And the purpose of looking at these possible zeros is to be able to find the rational zeros of a particular function. And so we only looked at a. And so the first thing I'm going to do is figure out what my possible zeros are. And then I'm going to use synthetic division in order to help me determine if something is a zero. So here my possible zeros are 1, 2, 3, and 6. And I'll know that a number is a rational zero if its remainder is 0 when I do synthetic division. So I'm going to start with the number 1 and do synthetic division using the number 1. I'll bring down the 1. I'm sorry, I messed this up. It should be a 0. Okay, because of this remainder, I know that 1 is not a possible zero of this function, or is not a zero of the function. Okay, if I do the same thing with negative 1, I find that negative 1 is a 0 for this particular function, okay, because the remainder came out to 0. So what I'm left with is x to the third minus 2x squared plus 3x minus 6, and I can solve this through factoring. So I have x squared times x minus 2 plus 3 times x minus 2 and when I separate and make each of these equal to 0, I see that one gives me this x squared equals negative 3, which is not real. And the other gives me x equals 2, which is another 0 of this polynomial function. So for a, my zeros are negative 1 and 2, and this is what I'm looking for.